good day, and welcome to the Africa Teen Geek. Yes, this is a STEM digital school. This is a STEM digital school. If you have just joined into this class, this is the grade 10 physical sciences. This is a grade 10 physical sciences. I hope that everybody is in the right place and ready to do some chemistry in this classroom. Today it is the 16th of July 2020, and as you all know, we recently started with representing chemical changes. So that is what we're busy with today. And it was quite, a short one. But I hope that the main important part is conquered, which is you guys understanding each and everything that we're doing in this chapter and in this classroom. Okay, when you go back to school, you must be able to interpret each and everything that is given to you. So my name is Nonkulilego Madondo. I am your physical sciences grade 11 teacher, and I hope that all is well and you'll be able to understand everything that we're doing. Reminding you guys that I'm working from the Siavula textbook and the Study Master textbook. So you have either or, then you're in a good place. But if you have any other CAPS approved textbook, you can indeed use it, and it'll also, you'll be able to follow through with what we are doing here. If you, however, would like to get your hands on these textbooks, you can go on Snaplify. Snaplify is an application that you guys can get on Play Store or even on your Google, and you download it and you get yourself some nice textbooks, different textbooks from different authors. You can get it on Simplify absolutely free until the 31st of December 2020 due to COVID-19. They've given us the privilege of getting all textbooks absolutely free. Okay, so let's get started. Sorry about that. Reminding you guys that amendments have been done in this case. Right now, we are busy with chemical changes, and the only thing that has been removed on chemical changes is reactions in aqueous solutions. So everything else stays the same. It's not going to be changed. The only thing is that they've brought all the chemistry together into one term. For term three, we're doing physical and chemical change, representing chemical change and quantitative aspects of chemical changes. And right now, we are busy with representing chemical change. So I hope that everybody is in line with everything that we are doing. Okay, that is our term three. Reminding you guys of the adjustments that have been made on the syllabus, as that chemical systems has been removed from the system, so you do not have to do it. You don't have to study for it as well. It's not going to count for anything. So it's going to be one paper for you guys, and and I hope that you guys are all ready to do some work. Okay, this was your homework for yesterday. This is our homework for yesterday. So yesterday we managed to do some balancing of chemical equations. Okay, and I hope that everybody understood how that gets to be done. But like I told you guys had homework. You had to do number 4, 5, 6, 7, 8, 9, 10 on your own. I hope that you were able to do that and you were able to get the correct answers. I don't know. I just hope that it was not as difficult for you after we did these examples. So let's go at it already, so that we can be able to start our next lesson. We're going to start with number 3. Number 4, we already did number 3, right? We're going to do number 4. Number 4 says um, calcium chloride and Na2CO3 react together to give you CaCO3 and NaCl. So it gives you a salt. Okay. So let's see how we can solve that one. Okay. So CaCl2 plus NaCO3 gives you Ca calcium carbonate and salt. Okay, so what we do first, remember what we do in our solution. First, we break them all down according to reactants and product. So on our reactant side, we're going to have Ca, and we're going to write the number of atoms. It's 1, and chlorine is going to be 2, and Na, which is sodium, is going to be 2, and C is going to be 1, and O is going to be 3. Okay, and then we write what we have on our product. Okay, so our Ca is 1, our chlorine is 1, our Na is 1, our C is 1, and our O is 3. So the only thing that's balanced so far is the calcium and the oxygen. So we now need to make a plan for chlorine and sodium. Okay, so we need to check here. Here's our chlorine, and here's our chlorine, and here's our sodium. But which means what we can do here, we can put a 2 over there, right? If you put a 2 over there, everything will be balanced. Okay, that's all we need to put in there. We just put a 2. So yeah, they've done that. We change the coefficient of NaCl to 2. So that will give us a balanced chemical equation. But don't forget, guys, immediately after you change, for example, now we're going to put a 2 over here. The first thing that you do after you put a 2 here, you put them back again in a comparison form. Okay, you write now how many Cas you've got, how many Cls you've got, because sometimes you might think that with the 2 you've got everything balanced, only to find that there's something else that is also not balanced. Okay, so make sure that you go back and you place your things in order, and then you can continue. So a balanced chemical equation is this, and we just added a 2 on the NaCl to balance it all out. So now we've got equal number of atoms for each and every element in this equation. Okay, moving on to number 5. So number 5, they've given us a bit of another complex one, which is C12H22O11. Gives you O2. So this is some type of a glucose, or sugar. I don't know what that is, but it's as you guys can see, it's a very large number. Plus O2 gives you carbon dioxide and water. Okay, so this is what we know as a combustion reaction. Okay, so now we need to write them out, all of them. As you can see there, we've written out what is our carbon. It's 12H22, and oxygen, we've got 13 because it's 11 here and 2 over there. So what do we have in our product? In our product, we've got 1 carbon, 2 hydrogen, and 3 oxygens. So now we need to balance it out. Okay. So in order to balance the number of carbon, we change the coefficient of carbon to 12. So we can first change the coefficient of carbon dioxide to 12, right? And now we know if we put a 12 in front there, we will have 12 carbon dioxide and 12 oxygen, and 12 oxygen. No, we're going to have 20, 24 oxygen and 12 oxygen, right? So there we have it. Now we've got our carbon. It's going to be 12. Oh no, we're putting it here. Sorry guys. We're putting it here. Put the 12 here. It's going to be 12 carbon dioxide, and we're going to have 24 oxygens, right? But it's going to be 24 plus this one over here. It's going to give us 25, and our oxygen, our H stays the same. So this is what we're now going to have. The only thing that we have balanced so far, it's our carbon. Okay, so we move on. Now we try to balance the H atoms, because here we've got 2 and there we've got 22, right? So we change the coefficient of H2O to 11. So we put 11 there just to balance out the H, because the H there is 22. So if we put 11 in front, it's going to give us 22. Okay? But now the oxygen has increased to 35. So, but it's fine. That's why I told you guys we need to be able to do it step by step. You take one element at a time, okay? So now you've got 22 on both H and H, the reactant and product, and you've got the carbon on 12 for both of them. So now all we have left is the oxygen that we need to balance out. But luckily for us, we've got an oxygen that's standing on its own that we can balance out. Okay, so what are we going to put there? We're going to put 12 of this oxygens. So we're going to put 12 there, and it's going to give us 24. We're going to put 12 right in front of the O2, and it's going to give us 24. Okay, plus what we already have, which is 13. It's going to give us 35. So this is how we balanced our equation. So our balanced equation will be C12H22O2 plus 12O2 will give us 12CO2 plus 11H2O. So it's always good, guys. You see, when you're trying to balance your elements and you've got one that is standing alone, start with the others first, and then you will top it up with the last element that's standing on its own. Okay, are we all good to go? I hope that we are well understanding. So number 6, let's see what number 6 actually says. It says barium chloride reacts with sulfuric acid to produce barium sulfate and hydrochloric acid. Okay. So the first thing that we need to do is write down the equation for the reaction. So you're going to have BaCl2 plus H2SO4 will give us BaSO4 plus HCl. Okay. So now we do the first step as usual, okay? We start with our reaction side. We need to write how much atoms we have for each. So for Ba, we have 1. For chlorine, we've got 2. For hydrogen, we've got 2. For sodium, for sulfur, we've got 1. And for oxygen, we've got 4. And then now we go again to our product side. On our product, our Ba is 1, our sulfur is 1, and our oxygen is 4. Then we've got our H as well, which is 1, and our chlorine is 1. So there we have it now. Now we know how many atoms we have for each so that we can know how much we need to do to balance it out, okay? So the Ba is fine, right? It's on 1. So the chlorine is our problem. So what are we going to do here? It means on the HCl, you're going to put on a 2. If you put a 2 on the HCl, then we're going to have 2 H's on both sides, and the Cl's, we're going to have 2 Cl's as well. So I think this one was quite a simpler one compared to the one we just did before. So in order to balance, we put in a 2 in front of the HCl. So now our reactants are balanced. So our balanced chemical equation, don't forget, guys, as much as you write what's your product, what's your reactants, you always need to write your balanced equation afterwards, okay? So this is your final balanced equation. So you're going to have BaCl2 plus H2SO4 gives you BaSO4 plus 2HCl, and our equation is therefore balanced. Okay, so let's go to number 7. They say the ethane reacts with oxygen to form carbon dioxide and steam. Okay, so now we need to balance the chemical equation. So this one on number 7, first we write the reaction, right? It's going to be C2H6. So whatever oxygen, whenever they write oxygen, you always know it's O2. It's not just the oxygen O standing alone, okay? So it's C2H6 plus O2 gives you carbon dioxide, which is CO2 plus H2O. So if we count the number of atoms of each element in the reactants and product side, we found that we've got 2 on the reactants, we've got 2 carbons, we've got 6 hydrogens, and we've got two oxygens, right? And the product side, we've got one carbon, two hydrogens, and three oxygens. So how are we going to deal with this? How are we going to deal with this on the carbon dioxide on this one? Because now we've got two carbons, right? We're just going to put a 2 over there, okay? We're going to put a 2 on the carbon dioxide. We're starting with this first one to balance out the carbon, right? So we start one element at a time. So we're going to start with the carbon and we're going to put a 2 here. So once you put a 2 there, then we're going to have um, we're going to have we're going to have four, five oxygens, two oxygens on the reactant side and five on the product side. But for the carbons, it's going to be balanced. Okay. So after that, we come to the H. Now we want to balance out the H2O. How much are we going to put there? There we're going to put a 3. Okay. We're going to put a 3 in front of the H. And how is that going to work out? Um, Now we're going to have two carbons, two hydrogens, and we only have to now balance our oxygen. So in order to balance oxygen atom, we change the coefficient of O2 to 3.5 and multiply all coefficients by 2 to get integers, okay? So basically, this is a one interesting part that I want to show you guys. So first, what we're going to do on the oxygen, on the oxygen, we're going to put the 3.5, right? After we put the 3.5, our equation will be balanced. But now we cannot have a fraction, okay? We only work with whole numbers, integers, as they say there. So what we're going to do to change this 3.5 to a whole number, we're going to times, we're going to multiply this whole equation by 2, okay? We're going to multiply this whole equation by 2 in order for us to get a whole number or get an integer. Okay, so it's not going to be 3.5. We don't write 3.5 there. We'd rather write 7, but multiply everything times 2. So that's why here there's a 2 now, and here from 2 changes to a 4, and here from 3 it changes to a 6. I hope that this is well understood. I like this problem, guys, because they all deal with different ways in which these questions can be structured and ways in which it needs to be solved. Okay, so going to number 9, it says hydrogen fuel cells are extremely important in the development of alternative energy sources. No, we move. I've just skipped one. We're actually on number 8, right? Ammonium carbonate is often used as a smelling salt. Balance the following reaction for the decomposition of ammonium carbonate. Okay, remember the decomposition reaction that we spoke about? We said we have one body and it slowly breaks down into small pieces. So that's what we have here. We've got one compound and the reaction gives you small little compounds that it's broken into. Okay, so let's see how that one was solved. It says ammonium carbonate is often used as a smelling salt. Balance the following reaction, right? And this is how we write it, okay? So now we need to balance. You know the first thing that we do, guys, we break them down according to each element. So how many nitrogens do we have? We've got 2. How many hydrogen gas do we have? We have 8. How many carbons do we have on our, we're still on our reactant side? We have 1, and our oxygen, we have 3. And for our product side, the nitrogen, we've got 1. The hydrogen, we've got 5 because it's 3 plus 2 gives us 5. And then our carbon, we've got 1. And our oxygen, we've got 2 plus 1 over there. That gives you 3. So we've got 2 balanced um, elements, which is the carbons and the oxygen. So now we have to start with the nitrogen. Okay. So what are we going to do with our nitrogen? Our nitrogen is 2, right? So all we do, we just add a 2 in front of the ammonia. This is a sign for ammonia. Remember, guys, I told you guys this is a NH3 is ammonia. So we just add a 2 over here. So we're starting with the first one to balance it out. And once we do that, our H is going to turn into a 6. Okay? And then we're going to have a 6, 7, 8. So it's going to be more or less balanced. So that makes our equation balanced. So this one was also quite a simple one where you just change one thing that fixes the whole equation. Okay? So our balanced equation is going to be as stated. We just added a 2. Okay. We added a 2 in front of the ammonia. And then we have our answer. Guys, if you're getting stuck anyway, please do send me a chat and I'll try and explain wherever you're getting stuck. But please make sure I don't pass anywhere where you guys, there's something that you do not understand. If you don't understand something, just drop me a chat and I will try my best to explain it as well as I can. Okay? So on number 9, it says hydrogen fuel cells are extremely important in the development of alternative energy sources. Okay? So this is our renewable energy sources, right? So many of these cells work by reacting hydrogen and oxygen gases together to form water, a reaction which also produces electricity. Balance the following equation. Hydrogen plus oxygen gives you water. Okay, so this one is another simple one. For us to balance the H2O, we just have to add a 2 in front of the H2O and add a 2 on the H2 gas, okay? Okay, so, but we do it step by step, right? So, first, what we do, we write out what we have on our reactants and what we have on our product, okay? So, okay, I forgot to put in the equation. So we're going to have H, we've got 2, and the oxygen gas, we've got 2. The H, we've got 2, but the oxygen gas, we've got 1. So the first that we do, we put a 2 in front of the H2O. So if we do that, it's going to be H2O to 2. Now we've got 2 hydrogens, 2 oxygens, 4 hydrogens, and 2 oxygens. But luckily for us, these ones are not joined together by anything. So if we change this one, this hydrogen gas alone, then um, it doesn't affect any other element. Okay, so it's going to be times 2. We're just going to add a 2 in front now, and it's going to be 4, right? And then this is what we're going to have eventually. We're going to have H4 plus O2, and the product is going to be H4 plus O2. And then our atoms are now balanced, and our equation is balanced. And this is what we will have, guys. I hope everything is coming all right. And then the last but not least, it says the synthesis of ammonia made famous by the German chemist Fritz Haber in the early 20th century in one of the most important reactions in the chemical industry. Balance the following equation used to produce ammonia. Okay, so now we finally have an equation that balances ammonia. So we're going to start with showing ourselves what has been given. Okay, so we've got 2 of nitrogen, we've got 2 atoms, hydrogen, we've got 2 atoms, nitrogen, we've got 1 atom, and H3, H, we've got 3 atoms. So the first thing that we do is going to put a 2 in front of the NH3, right? We're going to put a 2, and it's going to give us 6 and 9, right? No, it's 6 and 6. Where are we? If you're going to put a 2 there, it's going to be 2 nitrogens, and 6 hydrogens. There we have it. So you see what's happening here. It's not balanced. But luckily for us, once again, hydrogen stands alone. It's not bonded to anything that will alter the whole equation. So we just add a 3 in front of the hydrogen gas. And this is what we're going to have now. Now we're going to have 2 nitrogens, 6 hydrogens, 2 nitrogens on our product side, and 6 hydrogen in our product side. Okay. So now we have balanced the equation, and that takes us to the end of our homework. I hope that everybody got it right. It looked very doable, and I hope that it was also enjoyable for you guys. So now we need to continue with our work for today. Our work for today, we're going to state symbols and other information, and we're going to do our chapter summary. Okay. So state symbols and other information. The state or phase of the compound can be expressed in the chemical equation. Remember, I told you guys even when we were doing the symbols that there'll always be symbols that are required because you need to know in which phase your element is. So it is done by placing the correct label on the right hand side of your formula. The following 4 labels can be used. You can use G, which stands for gas. You can use L for liquids, S for solids, and AQ for an aqueous solution, which is basically a water solution. Okay. So to show that heat is needed for the reaction, a Greek delta is placed above the arrow. So whenever we're going to work with an equation that requires heat, we need to put a delta, a Greek delta or a triangle on top of the arrow to show that a heat has taken place. Okay. So here's another question. It says solid metal zinc reacts with aqueous hydrochloric acid to form aqueous solution of zinc chloride and hydrogen gas. Write a balanced equation for this reaction. So first, the reactant of zinc is Z, and the HCl is hydrochloric acid. The products are zinc chloride and hydrogen. So there we go. First, we do our first step. We balance the chemical equation by the first step, write it down as they want it. It's going to be zinc plus HCl gives you Zn Cl2 plus H2 gas, right? So you will notice that the zinc atoms balance, but the chlorine and hydrogen atoms do not. So since there are 2 chlorine atoms on the right and you only see one on the left, we will give HCl a coefficient of 2 so that we will be 2 chlorine atoms on each side, okay? So you just added a 2 in front of the HCl because the Cl and the hydrogen are the only ones that have 2. Then it's balanced. So now you need to check all the atoms are balanced. When you look at the equation again, you will see that all the atoms are now balanced, okay? So ensure all details, e.g. state symbols are applied. So if the rows bracket L, you need to know that if they spoke about a liquid, then you must know it has to be an L. If it has to be an aqueous solution, like they mentioned, you need to put your AQ in front of it. And if it's a solid, you need to put S, okay? And hydrogen gas is obviously a gas. They don't have to tell you. It's already self-explanatory. So these are how you gonna balance it out and how you label your symbols over here. You see, always good to label your symbol. So this is your homework, guys, that I'd like you guys to do. I'd like you guys to write a balanced equations for each of the following reactions. Include state symbols. Okay. So we're still gonna. It means that we're still gonna continue practicing our balancing of chemical equation, but we're gonna have some new work. Okay. So we're gonna do number 1, 2, 3, and 4. Okay. So please, guys, take a picture of this or a screenshot, and please try and do these problems. Okay. Okay. And then what we can do tomorrow, we can do our chapter summary tomorrow because I don't want us to start doing a summary at this time. We'll do our homework quickly and then go to our summary of the day. Okay. So thank you guys so much for a beautiful lesson. This is the STEM Digital School from Africa Teen Geeks. My name is Nokulego Matondo. I am your teacher for Physical Sciences grade 10. Okay. Let me just see if someone has something to ask. Please go back, okay, to the exercise. Okay, I'll do that quickly. Okay. So here is our exercise. So guys, please do the homework. If you do the homework and we come and do the corrections tomorrow, you will know what you understand. You'll know when you're getting stuck. So please, guys, make sure you always write your homework. And it will give you guys a better understanding, especially when we're doing corrections, okay? Okay. Thank you guys so much. And have a beautiful afternoon further.